So the first type of application question we're going to go through is the shortest distance one from analytic geometry. So it says determine the shortest distance from the point 5, -3 to the line that passes through the points -6, 2 and 3, 5. Now this is the longer version because I don't give you any equations of lines. So I already plotted my points, and I know that I'm going to have my line going through BC, and I need to figure out the shortest distance from A to that line, which means our first step is going to be find the equation of the line. One equation of BC. Okay, so I have 2 points, so my first step is going to be find the slope. So y2 minus y1 over x2 minus x1. And I'm going to simplify that. I'm going to simplify across just to save space, but usually you should work down. So I have 3/9, which simplifies to 1/3. Okay? I can use any point I want for my equation, but I'm going to start off by writing y equals 1/3x plus b. I'm going to plug point C in just because the numbers are a little smaller. And now I'm going to simplify. Remember, when you're multiplying by a fraction, if you want, put the whole number over 1. And multiply the top, multiply the bottom. So 1 times 3 is 3, 3 times 1 is 3. And if you can, simplify. 3/3 is 1. And now we can bring that 1 over, and it becomes 5 minus 1, which is 4. So our first equation is 1/3x plus 4. And if we look at our drawing, that is the y-intercept we got, so we know we're kind of on the right track. Now we can find the equation of the altitude. So when I find the altitude, we want to be perpendicular to our line. So it's going to look something like this, okay, but obviously a little better. Okay, that's just a rough estimate. So that's the equation I'm going to try to find now. So step 2, altitude equation. Now I know the altitude is going to have a perpendicular slope to the equation we just found. So the equation of AB was 1/3, or the slope of AB was 1/3. So the perpendicular slope is going to be -3. And I know my altitude passes through point A only, and that's located at 5, -3. Okay, and now we can find our equation. So I plug my slope in, y equals -3x plus b, and now I put my point in for x and y. Let's clean it up a little bit. -3 times 5 is -15, and when I bring that over, I have -3 plus 15, which is 12. So my equation is -3x plus 12. Now if we go to our graph, this is what we have so far. We know the equation of BC. We know the equation of our altitude. Now I want to know, where does this altitude meet my line? Because if I can figure out that point, I can find the distance between that point and A to calculate the shortest distance. So that leads us to step 3, which is find the point of intersection. I'm going to write out my equations here on the side. So 1/3x plus 4, and the other one was -3x plus 12. Okay, so now whenever I have a fraction, I use substitution, and I just set those y's equal to each other. And I'm going to use that quick trick in a second to get rid of the fraction. So to get rid of that fraction, I'm going to multiply everything by the denominator, which in this case is 3. So 3 times 1/3 x is x, 3 times 4 is 12, 3 times -3x is -9x, and 3 times 12 is 36. And now we can do a swap. Make sure you're changing the signs when you move terms to opposite sides. Okay, so now I have 10x is equal to 24. Okay, I'm going to divide both sides by 10. And when I divide by 10, I'm just going to write my x as a decimal because I'm going to use the distance formula later on. And I said in class that it's okay for your point of intersection only to be as a decimal so that you can use it later on. So now I'm going to plug it into my easier equation to figure out what y is equal to. You can technically use the other formula as well, but this is just going to make life a little easier. Okay. And when I simplify that, I get 4.8 for y. So my point of intersection is at 2.4, comma 4.8. And now we can find the distance between this point and point C, or A. Yeah, point A. So let's go to step 4, which is distance. We're using our point of intersection, and we're using point A, which was at 5, -3. So if we don't remember the distance formula, it's x2 minus x1 squared plus y2 minus y1 squared. So now I'm going to plug my values in. 5 minus 2.4 squared plus -3 minus 4.8 squared. Okay, you can jump to the answer here or jump to one step. I'm going to go the long way. 5 minus 2.4 is 2.6, and I'm going to square that later. -3 minus 4.8 is -7.8 squared. Let's raise each number to the power of 2, so that's 6.76. The other one is 60.84, and now we can add them up to get 67.6. Because there's already a decimal on there, I'm just going to write my rounded answer, which is 8.2 units. And this right here would be my final answer, 8.2 units. The shortest distance from point A to the line created by BC is 8.2 units. So just to recap, okay, 1, find general equation. 2, find the altitude. 3, your point of intersection. 4, use the distance formula. And that's it. And the second type of application question that we're going to look at is the center of a circle. The points A, B, and C are located on the circumference of a circle. We want to figure out the center. So I already plotted my points, and I drew in 2 chords. So a line segment between AB and one between BC. The center of my circle is going to take place at the point of intersection between the right bisectors, which means I need to figure out the equation of the right bisector of AB and the equation of the right bisector of BC. So once we do that, we can find the point of intersection between the two, and that would be our center. So step 1, perpendicular bisector of AB. Now bisector should make you think of midpoint right away, so let's calculate that. -3 plus 2 over 2, and then negative plus 2. Let's simplify that. For the x-coordinate, it's just going to be -1/2. Don't turn it into decimal. For the y-coordinate, it's going to be -4 over 2, which is just -2. Now, perpendicular, you know you're going to take a negative reciprocal. So the first thing we want to do is find the slope so that we can take the negative reciprocal of something. So I'm going to have 1 minus -5 and 2 minus -3. And that gives me a slope of 6 over 5. My negative reciprocal slope is going to be -5 over 6. Now I have the slope that I'm going to use, and I have the point that I'm going to use to find that perpendicular bisector. So let's go ahead and do that. Y equals negative 5 over 6x plus b. I plot my point, or I plug my point in, negative 2 for y, negative half in for x, and now we simplify. So negative 5 times negative 1 is 5, 6 times 2 is 12, and now we can bring it over. Now, because I know I'm going to bring it over, and it's going to be subtraction of fractions, I need a common denominator, so I'm going to turn that negative 2 into negative 24 over 12. When I simplify, so I subtract the top numbers, I have negative 29 over 12 from my y-intercept. So here is our very first perpendicular bisector equation. Okay, a little messy, but that's okay. Now that we got the first one, now we need to go find the second perpendicular bisector equation. So I'm going to do that over here so that I can see my points. The perpendicular bisector of we said BC. I'm going to write my points to the side so that I don't have to go back and forth. Okay, so let's start off again with our midpoint. 2 plus 10 divided by 2. 1 plus negative 7 divided by 2. And here we're going to get nice whole numbers. 12 over 2 is 6. Negative 6 over 2 is negative 3. Midpoint's done. Now we go to our slope. Negative 7 minus 1, 10 minus 2. We get negative 8 over 8. So that's great because that becomes a whole number. Don't forget to take your negative reciprocal, which in this case is going to be 1. So here's my perpendicular slope. Here's my midpoint. Let's find the equation. Y equals 1x plus b. Let's plug our point in. Nothing to simplify, we just have to bring the 6 over, so we have negative 3 minus 6, which is negative 9. So our equation is y equals x minus 9. Okay, now that we have our two equations, we can go to our final step, which is find the point of intersection. Okay, so step 3, point of intersection. I'm just going to write my two equations. And because we have fractions, I'm going to use substitution. Okay, so I'm going to set my two y's equal to each other. And I don't want to deal with those fractions. Now I have 2. The common denominator between 6 and 12 is going to be 12. So I'm going to multiply everything in that line by 12. So 12 times negative 5 over 6 is going to be negative 10x. 12 times negative 29 over 12 is going to be just negative 29. 12 times x is 12x. And 12 times 9 is 108. And now we can do a little swap. So negative 10x minus 12x, change the sign, and negative 108 plus 29. So on the left we have negative 22x. On the right we have negative 108 plus 29, which is negative 79. Let's divide both sides by negative 22, and you're left with 79 over 22. We can't simplify that. All I did was got rid of those two negatives because they became positive. Now I can plug this into one of my equations. I'm going to plug it into the x minus 9 because it's a lot easier. Okay, I know I'm going to have a common denominator, so right now it's 9 over 1. So I'm going to multiply top and bottom of my second fraction by 22. So 9 times 22 is 198. And now we can do 79 minus 198 and get negative 109 over 22. So our center is at the point of intersection, which is 79 over 22, comma, negative 119 over 22. If you want to look at your visual and see if you're kind of in the right location, we can turn these into a decimal just for our reference and for our peace of mind. So it's 3.6 and negative 5.4 roughly. Let's see if that's kind of what we had in our diagram. 3.6, yeah, and around the negative 5 point something. That's perfect. So there it is. Okay, so just to recap, the steps for finding the center of a circle are 1, create chords, 2, find perpendicular bisector of each chord. You only need 2. And step 3 is find the point of intersections. When I say create chords, just pick what your chords are going to be, A, B, and B, C, and then find the perpendicular bisectors of each one. And that's it. Hopefully that these types of application questions are a little better now. Don't let fractions mess you up though. The actual steps are familiar and they should be okay. Just don't let the fractions mess you up.